Hello, everyone. My name is Damon Bassetti, and I am the person at DLC responsible for our horticultural program. Thank you for joining us this afternoon as we discuss our first draft of our what we're calling version 1.2 of the horticultural technical requirements. Please bear with me for one more moment. We still have some attendees trickling in, and we want to make sure we have everyone here with us before we start moving. All right, the join rate seems to be leveling off, so I will go ahead and proceed, and welcome to any late users who join us partway through the presentation. So like I said, my name is Damon Bassetti, and I have several other staff with me as well, Casey Holland and Dave Ryan. And together, we work on and administer the DLC's horticultural lighting program. As part of our program, we regularly put out draft requirements for how we want to change the specification and technical requirements to make it adapt better to this rapidly evolving landscape to meet the needs of end users, electric utility efficiency programs, and manufacturers of horticultural lighting equipment. As part of that, last week, we released a first draft of what we're calling version 1.2 of the horticultural QPL technical requirements. And this webinar is to both explain them and make sure you understand what we're proposing and to make sure that you have an opportunity to ask questions of us as well. Because of the large number of attendees who are with us today, we've muted everybody. And so if you have anything that you'd like to bring up, you should have an easily accessible chat window in which you can type your question at any point. My colleagues Dave and Casey will be managing this and typing responses. And then if something seems like it requires, I guess, verbal discussion as part of this, I'll go ahead and be periodically asking Dave to speak in the voice of the person asking the question, and we can go ahead and discuss it that way. So having said all of those housekeeping things, let's go ahead and get going. And thank you again for joining us today. All right, after today, we are going to be posting these slides on our website, designlights.org, after the presentation. So you'll be able to take these and share them with your colleagues very easily and quickly. Ask questions to the question pane, and the comment period is now open. Please give us your comments by the end of the day on September 3rd, a little bit under a month from now. The comment forms on our website, we ask that you give us your comments in that form. It helps us be efficient and make sure we don't miss anything rather than parsing text of email bodies. We might get it, we might not get all of it, depending on the volume of products or of comments that come in. So by using the standardized form, easily located at designlights.org, this helps us make sure that we are getting everything from you. Please email that to horticulture@designlights.org. If you do email to one of the other DLC addresses, of which I know there are many, don't worry, we'll go ahead and forward it on over ourselves to make sure that we hear your voice and your input is considered as we do the final optimization of the spec. So if you go to designlights.org, go to horticultural lighting, the DLC work plan, Hort Lighting V1.2. It's that nice big red arrow that you see down in the comment form, along with downloading the cover letter and the actual draft policy itself, if you want to do things like refer to line numbers and things like that. Okay, today I have already welcomed everybody. I'm going to next briefly review what we are and how we develop our specifications here at the DLC. Then I'm going to review the actual draft spec itself. There are three main areas in this presentation, and then there's going to be time for some Q&A if it doesn't opportunistically arise before then. So how do we go through our development process? Well, we certainly don't just sit around and idly daydream about what would be an interesting thing to work on. We hear from people all across the industry, end users, utility programs, manufacturers, test labs, standards bodies, almost every single day about things that we could do better, do differently, or areas where we could add more value to the landscape. And so we get a bunch of input from a bunch of different people. We go through a slicing and dicing and weighting and analysis. We prioritize everything, and then once everything makes it through that filter, testing it both internally and then with our other working groups, for example, our horticultural working group, then we put a draft policy out with public comment periods to make sure that we are hearing from every single stakeholder in this industry. We are only effective because we get good feedback from stakeholders like you. We like to think that we're pretty knowledgeable about these things, but there's no way that whoever we have working here, that we can begin to approach the accumulated expertise and experience and knowledge of the overall larger community. And so, as part of this process, we collect everything, we take our best guess at it, we put out a draft, and then we hear from you. And like today, we're here mostly, well, initially to explain, but then to listen as well. With what you give us, we then make the draft policy better. If necessary, do a few more cycles, and then we finalize it and put it out as final policy. And the idea is that no one should ever be surprised by what's in the final policy, and that there's ample communication and lead time for everyone to adapt to how the policies do change. And here is how the specific timeline that is planned for the Hort v1.2 implementation. So we released it on July 30th or 31st, 2019 in the draft on our website, and we sent a big email blast. We are now in the comment period. We've already received, I think, 3 different stakeholders have sent comments back to us, and we're processing them as they come in. We're planning to have version 1.2 for horticulture take effect on October 15th, 2019. And through the winter period of 2019 to 2020, there are some implications of what we're proposing, and that will require some product updates. We're going to be working through a customized product update process with those product owners through that period. We'll explain more about that in a little bit. But then the last real date that's kind of on the wall for this is that products without PPF or horticultural-based units for demonstrating their flux maintenance will be delisted starting in April 2020. And we'll speak more about this when we get to that section of the proposed requirements changes. Dave, anything before I start diving joyously down into the technical details?
No questions yet, Damon.
Okay, thank you very much. All right, now it's time to go through the draft specification itself. So our first proposal, and this is probably the single biggest mechanically, philosophically program change that's contained in this minor draft change proposal, is to make DC powered fixtures eligible for our QPL. We explicitly excluded those fixtures from our first version of the QPL that went live in October, and our general requirements that went live in October of last year. We were concerned about how to fairly compare the performance of DC and AC fixtures. And that's electrically, but also optically, in terms of if you have DC fixtures that are on a flexible cord, perhaps, that could be mounted in different or differing orientations. How do you actually test the thing that is in the goniometer, that is in the integrating sphere, and make sure it's relevant to any kind of end state or use case, how it's going to be used in the field. So what we proposed is to require fixture-based testing of, I guess you might describe it as the smallest severable element in that system, the fixture, making sure that that testing is occurring at the designed DC state for that fixture. And so if you have a thing that makes light that is plugged into a DC remote power supply, that light or that fixture would be the thing that is tested in a goniometer or in an integrating sphere. And if you could put 1 or 5 or 8 or 50 on a remote DC power supply, and they're all the same SKU, then that single element would be the thing that is tested. And if you had 5 or 6 or 10 different styles, colors, optical distributions, each unique blend of those would be the thing that is tested. So that would then give manufacturers and installers flexibility of installing them and stitching together a system as they see best. All that being said, the key thing here is to test that fixture at the designed DC state for that fixture. Because of concerns about DC and AC efficacy specifically, we're not catching the rectification loss from the utility's perspective of who provides you AC power. we are going to then, we're proposing that we then adjust power and efficacy values by a static weighting factor. And these updated values, i.e. the non-DC ones, but the adapted, quote, equivalent AC ones would be those that are displayed on the QPL. Probably asking yourselves, what is this weighting factor? How are you picking it? How's this going to work? We'll get into that. But the key thing that was motivating our work on this is we kept saying to ourselves, we're pretty sure that we're not the first people to have this problem. Someone somewhere has already faced this issue and solved it. And I'm glad to share that someone has. And this is a picture of a data center. And if you think about what goes into building a computer or data center, like the ones that Facebook and Google and Dropbox and Amazon have all been building around the world for the last decade or more, is that those all run off of big, high-power DC power supplies. And there is an industry-wide standard for describing the efficiency and performance of these high-power DC power supplies. And that standard is called the 80+ standard. And this was originally designed and put out there to ensure that computer power supplies were at least 80% efficient. But it has since evolved to have several different performance levels, usually tied to the names of precious metals, so gold, silver, platinum, titanium, and so on, that describe different performance levels, interestingly, at different power loading states as well. The 80+ standard, from my background research and speaking with knowledgeable practitioners in the sector, has about an 80% market share globally. That is, 80% of all DC power supplies in this high power range are 80+ certified. So there's a large market that's available of off-the-shelf OEM equipment ready to go. The testing infrastructure for this is mature. It's the testing protocol for 80+ was devised by EPRI, the Electric Power Research Institute. It's administered on a continuing basis by ClearResult, a nationally known program implementer, and it's a fast, standardized testing turnaround and listing procedure. If you're familiar with how LM79 testing and DLC certification works, you would probably be very familiar with what it looks like to work with the 80+ program as well. Like I said, there are a range of different performance levels. So there's the base, which is just 80+. Then there's bronze, silver, gold, platinum, and titanium with different test points at different power efficiencies required of each. If you were to average it out, for example, the testing at 20%, 50%, 100%, you would get one single synthetic average for that level. And this is per the 80+ program managers who I've been speaking with. So if you were to say, hey, what's the efficiency for the gold level? You would be able to say 88% on average at the 115 volt supply. So like I said before, what we're proposing to do is have DC powered remote fixtures or remote DC powered fixtures be tested at whatever it is the designed DC state is. Maybe it's 12 volts, maybe it's 48 volts, maybe it's something else. But whatever you design it to as, max output, max current, that's going to be the worst case, quote, condition for it thermally. For all the other kind of historical ways that we at DLC have asked you to test your fixtures, just test it like that in its worst case DC state. Then we are proposing to pick a standard efficiency value and just derate the DC fixture performance during that process. It's going to be a single static transformation that's going to have the result of efficacy going down and the power going up. And these would be the numbers that go into the QPL. And these would essentially give the end user who's paying an electric bill based off of a utility electric meter, utility energy efficiency program, a way to compare apples to apples and oranges to oranges in terms of power loss and energy efficiency perspective. We also are proposing to recommend that our member utilities set a program requirement that if you are using remote DC powered fixtures in and applying for a horticultural lighting incentive based off of the DLC Hort QPL, we are going to ask that you also demonstrate that are using them with a power supply that is at least that same level on the 80+ list. The idea being that the efficacy number we're publishing and promulgating on our website here at DLC is based off of that efficiency value. And so if it's less than that, then the utility would see a lower effective efficacy. But if it was higher than that, then perhaps they might be inclined to give you an extra adder because you're being even more efficient. The big thing that drew us to this approach was that from a fixture manufacturing standpoint, there is no real increase in test complexity or lead time or review cost. There are no extra tests that we're asking manufacturers to do. It is simply throw it in the sphere, throw it on the gonio, and do your test. Power it according to different conditions, obviously not AC but DC, but those facilities at all the different testing laboratories are equipped for this setup already. There's no administration that we are trying to impose on the driver world or the power supply world. We're not adding anything else. So we're not trying to make a DLC driver spec. Instead, we're just looking at something else that has already successfully addressed this concern and picking it up and using it there. And simple and fast to review as well from our perspective. And the effect of this is that users of the Horticultural QPL will see a single wall plug equivalent efficacy and power value for both AC powered and DC powered fixtures. So they can look at two and compare them on all the different parameters and know that there won't be any surprises from an energy and power perspective. Here's how that math would probably work out, or how as we're proposing it today. So in the first equation that you see, now I got a C in calculus, so if I can do this, you can probably do this too. But we're simply proposing to take the power that we see in the DC test for the fixture on an L7N report and divide it by a number that is less than 1, because that will be the efficiency value of that 80 plus number of the power supply that's nominally being paired with. That would have the effect of increasing the power that goes on the QPL, the power AC on this equation. In the second equation on the right, you would see that that same efficacy that's measured in an integrating sphere would be multiplied by that same number that's less than 1, which would be your 80 plus derating factor, having the effect of decreasing the PPE. The PPE is the threshold number, so that would have the effect of, depending on where we choose that derating factor to be, it would make the minimum efficacy that our reviewers are looking for on a DC powered fixture to be somewhere in the 2.1 or 2.2 micromoles per joule of ppf range. Because when multiplying it by the derating factor, that would take you to that 1.9 minimum level that we have now. We propose a derating factor of 92%. That seems kind of high, but this is equivalent to the 80 plus platinum performance level when at the 230, 240 volt level. In doing so, I went through and did the numbers on what's been on the 80 plus list and when they got listed. At least about, there's some up years and some down years, about 30% of products in the entire 80 plus program in the past 4 or 5 years have been at the platinum level. When you add the next higher level, platinum or titanium, in some years they're cracking north of 40%. And so that means almost half of all products are at least 92% efficient or greater. And again, this is important to note, at that 20, 50, 80, and 100% performance level of load, which is important if you're thinking about a one-to-many power supply to fixture setup, in which you may not be certain as a utility or an end user how many downstream devices are going to be coming off that power supply. So the result of this is that we feel that there is a large and mature global supply of products that can be plugged into this with minimum disruption, and we think great outcomes for the end users. Finally, let me pretend to be an electrical engineer and compare AC/DC systems, because some of the feedback we've gotten and some of the very justified concerns are, well, aren't there other differences between AC systems and DC systems? Are you sure that you're actually going to be, there's not going to be some kind of other efficiency loss somewhere? So allow me to quickly breeze through my view of what these are and how I think we're managing the risks of comparison. So in an AC powered system, we have a distribution pole outside, and it comes down into the building. And then it goes through circuit breakers and wires, and there's loss in those wires as well. Then we get into the area where DLC specs come into play. So there is the rectification from AC, which is that squiggly line, down into DC, generally internally within the fixture. And then there's optical losses. That little shape is supposed to be a lens. But if you have optics, light bouncing around within the fixture before it exits, all of that is wrapped up in the fixture product performance testing that DLC requires and mandates for AC powered fixtures today. Then finally, there's another stage of distribution losses in the application layout itself. How are the lights spaced? How far are they from the plants? What are the angles of distribution? And how does that relate to everything else? So in all of these different cases, you have some efficiency losses here in the application, which we can't do anything about here at DLC. We're trying to encourage best practices, but that's kind of an expert domain of lighting manufacturers and design consultants. We have how efficiently the fixture itself makes power or makes photons out of electrical power. But then upstream, we also have some transmission distribution losses, which are invisible from our perspective. But if you're doing wiring in accordance with National Electrical Code in the US or Canada, you're never going to see losses more than 3% in a branch circuit and 5% on the overall circuit breaker for the main panel downstream. So that's, if you think about it in a kind of a high level aspect, that's your upstream losses. Obviously, we're not talking about step down transformers or things like that, but I think that's safely enough outside the purview of our area here. Dave, is there anything to bring up before I go into my understanding of DC systems?
The only question we've gotten so far is a question really on the SSL program about whether there's any anticipation that the DC policy in the SSL program will be adjusted to follow the same principle with 80+. Do you want to comment to that?
The programs are running generally independently of each other. I think if we can show some successes with the 80+ program here, it will probably make a strong case for adjusting our stance, but we're not explicitly tying ourselves to that yet. So if we can be successful, maybe. If not, and I have to embarrass myself and walk this all back and change it in a year from now, maybe not. I think and I hope that this will be successful. All right, now I'm going to go through what a DC system topology might look like. So as far as I know, there are no DC powered large scale transmission distribution networks in most places. So we start with AC power coming off the pole, comes in the factory. And then obviously there's upstream trip protection. But before we get to the distribution circuits going down to the light fixtures, this is where we're doing the rectification from AC to DC. And this is an area that 80+ testing and certification would cover. Then we go down back into the wiring system. So you have special DC circuit breakers and special DC wiring cabling that oftentimes are thicker than normal AC wiring because of the current losses you have to be worried about. But again, if you are installing these systems to National Electrical Code, you will, for thermal safety reasons, not be exceeding 3% loss in a branch and 5% in the overall system. So again, that's equivalent to what the wiring losses should be in an AC powered system. Then you get back into the area where DLC coverage can, the actual generation of photons within the fixture and the distribution of photons coming out of the fixture. And then we come back into the application layout, something that we can't help you with quite yet, or perhaps ever, but an expert in the design and usage of these systems would be able to manage to give you the best outcomes for your crop. I'll pause here, Dave. Are there any more questions about our AC DC system overlay and how I think, my explanation of how I think this will give utility program managers and other users apples to apples comparison of the two types of products and their performance?
No additional questions at the moment.
Cool. Thank you, Dave. All right, well, please continue to noodle on those while I go through our last two. I promise I will not talk as much about these two because these are a lot simpler and less technically complex. So for our second proposed policy change, there's nothing new, nothing surprising about this. We're simply proposing to implement what we had promised we would do a year ago, which is to, I guess the root cause was the industry was working with what we had. And what we had were largely phosphor converted white LEDs that had fantastic lifetime lumen maintenance values because the industry has worked really, really hard on solving this problem. But because the only use case for the last decade or so was human or lighting for human eyes, everything was denominated in lumens terms, largely. And so LM80 data takes about a year to collect, and sometimes more than a year, depending on how long someone wants to run the test chamber. And so telling the industry that they were locked out from using these products that were probably perfectly good, and would have to stop selling, stop installing, and have to run back through the test chamber sequences to get a new LM80 data set solely in PPF terms, we felt was a non-starter. So what we've been doing for the last year is we are accepting qualification of products with LM80 data that's in radiometric watts or in lumens-based terms, i.e. non-photosynthetic photon flux. However, at the start of the program, we said, we have a year to do this. If you do not have PPF-based LM80 data, then we are going to stop accepting it in new product applications starting on October 15th. We are simply proposing to carry out what we have already said we are going to do and require that new products that apply to us starting on October 15th will be required to use PPF-based data. And I'm saying PPF, but if we're asking a question about far red, obviously we would ask for that to be in far red terms as well, or photon flux terms in that far red band to demonstrate the flux maintenance. I want to highlight that if someone has an application in to us before October 15th and the review process has not completed by then, that's fine. We're not going to pull the rug out from underneath you. We'll work with you on that. But if you have, if we have accepted your product with non-PPF based terms, either natively measured or with a static conversion factor, which was an alternate compliance path for us, then we are going to be contacting you throughout the winter to request an update to your product. And that could be potentially a component change, or it could be, hey, it's the exact same device, and the OEM has now given me this new PPF-based data set. Either way, we'll work with you on it. The exact process is TBD. We don't have anything we could lay out for you right now, but it's something we're working on defining and developing. And our goal is to make this as easy to work with and fast and I guess quick as possible. So we don't want to make this difficult. It's not going to be a pain. This is going to be something that we're working together on to get your products updated. Dave, any comments, topics here?
No questions have come in at the moment.
Okay, cool.
At this point.
And if there's any of my LED OEM friends on the call, thank you again for working with us on this. Anyone who's not an LED OEM, I think literally every single person you can imagine buying LEDs from, we've been speaking with over the last year about this, and every single one of them has been assuring us that they are ready to supply their customers, i.e. Fixture manufacturers, with PPF-based LED data. So if you haven't heard from them, please reach out to them and ask for it because they're ready and they want to make you successful. Finally, our third proposal is to delay requiring TN33 based data for another year until our 2.0 revision is planned. At the root of this is the question of making sure that end users can have PPID, which is intensity distribution data. Oftentimes, I guess what light is leaving the fixture in what direction, and SQD or spectral quantum distribution, or what is the wavelength composition of light leaving the fixture. Right now, we're only requiring kind of static images that are generated by manufacturers or test labs because there's not quite a standardized format yet for doing so. The TN33 format does have technical capability to do this. However, it is a new standard and the adoption is spreading, but it is not yet widespread enough in terms of the testing infrastructure, the software packages, et cetera, where we feel comfortable requiring everyone to use it in about 2 months from now. It just doesn't seem to be quite there. But we're going to keep pushing our outreach to our manufacturers, our standards friends, our test lab friends, and to make sure that it is ready for us to switch over to by October 2020. Especially when you consider things like how there seem to be different trends emerging in the application space for horticultural fixtures, things like intra-canopy versus top lighting, or even sub-canopy lighting where lights are down pointing upward. Being able to easily process and evaluate PPID seems like it's going to be extremely important. And right now, you can do it with the Mark I eyeball, looking at a bunch of different JPEGs of that, but that does not really scale very well. And we're hoping to, you can imagine similar issues for SQD data as well. So we're hoping to make the data easier to work with for both us and our reviewers, and also for everyone downstream in the industry, so we can all move to this great new standard format. So we're proposing to relax the requirement of TN33 for another year. So in summary, we're proposing to make three changes, one relatively significant, I think, one that wasn't really telegraphed beforehand, and two that generally were. And so the DC remote power supply is the big one, and the two more kind of nuts and bolts ones are the TN33 and the requiring horticultural specific terms for flex maintenance. If you have questions about this, I'm about to ask Dave for some more, but we also have our comment form on our website and our draft spec requirements as well on our website. You can download them, peruse them at your leisure, and the comment period closes on September 3rd, end of the day, 2019. Dave, anything else for to discuss?
Question on how we treat, and the phrasing here is family reports. So if there is a LED that is covered by an older LM80 report that currently doesn't have PPF or Hort-specific units, will that be able to be used?
If there is an older report that is not in PPF specific units, well, I guess stepping back a bit, I think we rely on the LM or the Energy Star guidance for using any LM80 data from one part for another part. So if that applicability criteria has been satisfied, I guess I would say that we are expecting to have whatever the data source is, which we're deciding to evaluate in the TN21 calculation extrapolation, we would expect it to be in PPF terms. Does that answer the question, Dave?
Yeah, I think so. And maybe just to, in case there's confusion on this point, if there's an older report that was covering a package, if that report is in lumens or anything that's not a Hort-specific unit, the proposal here is, and as Damon mentioned, it's hopefully not new information to the folks who've been tracking the Hort development, specification development over the last couple of years. But the proposal is that starting on October 15th, we will no longer accept those non-Hort unit reports for new qualifications at that point. So the older type reports that are being referenced here wouldn't be accepted after October 15th.
And we would be asking those who previously passed during the one-year grace period to instead update their information or face delisting in April. So essentially gives a 6-month period is opening in October, during which DLC staff will be contacting manufacturers of products that did take advantage of the lumens window, for lack of a better term, in the first year of the program to qualify with LM80 database and lumens, and asking them to update. And those that successfully update will stay on the QPL. Those that remain in lumen-based terms, for whatever reason, will still be allowed on the QPL through April 2020 and then be delisted. Our goal is to have everything on the QPL have a solid basis in horticultural native terms for their LM80 flex maintenance, because that's such a critical life-limiting component for both utility energy efficiency measure life and end user satisfaction.
All right, so we actually have 2 additional questions that have come in, both about the DC proposal. So the first one here is a question on what would be considered worst case for a given DC fixture. And particularly there are questions of, do we have to evaluate, quote unquote, every spectrum? So if I can comment to that, the proposal here is that within a specific fixture, for example, if a DC fixture accepts a range of input DC voltages, then the testing conditions have to be at whatever the worst case is for that particular fixture and how the components and, for example, the DC to DC driver that voltage might be going into, whatever that specific fixture's worst case would be. In terms of spectrums, the program requirements aren't proposed to change. There's not a family grouping approach in the horticultural program. So different spectrums would be considered different fixtures and would need their own independent evaluation.
Thanks, Dave.
Anything to add to that, Damon?
I would say if anyone is confused about what we mean by worst case, we have a template spreadsheet on our website posted for um, what we call benchtop driver evaluation in the AC context. But essentially, if you, knowing nothing else, if you had, say, a fixture that could operate off of 24 to 48 volts DC, we would expect and look for benchtop testing, i.e. not in an accredited laboratory, but just benchtop testing in your own facility, showing the power in, power out of the fixture at the 24 volt case and the 48 volt case and the resulting efficiency. And then we would ask for whatever the official accredited lab testing to be done at that lowest efficiency level. Probably the 24 volt case because it's the highest current and current losses predominate in that context. But we see other stuff sometimes too.
Great. So the next question is regarding, again, DC products, and if we have any commentary on sort of defining what a remote driver or remote power supply might be. I think the implication here is that you may have sort of a remote driver that's one-to-one with the fixture. It just may be outside the fixture housing versus a remote driver or remote power supply that is much larger and servicing a whole room or maybe a small group of fixtures. And where do we draw the line on what would be within the DC part of this program with the D rating proposed?
An excellent and nuanced question. Thanks, Dave. Well, in the past year, we have, in the spec, we've actually allowed one-to-one remote drivers, and our guidance to our reviewers has been to not disallow a product simply because it has a driver that is made to be mounted off board shortly thereafter. I think our guidance to the review team was something along the lines of, if it is more than an integer multiple difference, the power supply capacity versus the, then to begin asking more questions and probe more deeply into this. And so I don't know if I have a clear defining line or limit on this and how we would consider it, but I would certainly seek commentary from everyone on this call in terms of how they think would be a fair way to adjudicate this.
All right, I think that's it for the moment.
Okay. Well, that wraps up our presentation. And so on behalf of the horticulture team here at TLC and DNR International, me, Dave, Casey, and Rose, thank you very much for both your continuing interest in our program. We want to make you successful. We want to make the program successful. And the direct input for that success is the comments and wisdom that we get from you throughout the comment process. So please go to our website, please send the comments in, and please let us hear from you so we can go ahead and synthesize everything into a fantastic final spec that takes effect on October 15th. Dave, any last parting questions or thoughts?
There are a couple of additional questions in the question pane, but for you folks, I'll be following up with you individually. And as Damon said, we encourage everyone to send in comments through the comment period. We'll be looking at them all very closely, and we appreciate all the engagement and feedback from the community.
Excellent. Thank you, Dave. Thank you, everyone else. And please have an excellent rest of your day. Bye.